Right now, as you are watching this, scientists are warning that the heat wave itself is not actually the most dangerous part of what we've been living through this summer. It's what comes right after it. A new study just found that a specific damaging chain reaction, heat, that triggers sudden severe drought, is spreading across the planet at an accelerating rate. In the 1980s, this kind of event covered about 2.5% of Earth's land in a given year. By 2023, the most recent year researchers had full data for, that number had climbed to nearly 17%. And the researchers are blunt about what's driving it. As the world warms, heat waves and drought are not just becoming more common on their own. They're starting to trigger each other, building dangerously off one another in ways that make the aftermath of a heat wave just as dangerous, sometimes more dangerous, than the heat wave itself. Today we're going to break down exactly what this chain reaction is, why it's accelerating, and what it actually means for the parts of the world already living through it right now. If you want to understand what's actually coming next this summer, instead of just reacting to whatever the headline of the day is, subscribe and turn on notifications, because we track this stuff as it develops. Let's get into it. Researchers from South Korea and Australia set out to answer a specific question. Is the 1-2 punch of heat followed by drought, what scientists call a compound extreme, actually becoming more common as the planet warms? Or does it just feel that way because we're paying closer attention? The answer was unambiguous. Compound heat drought extremes are increasing, and the specific type getting worse the fastest is the version where heat comes first and directly triggers the drought that follows. That specific sequence covered roughly 2.5% of the planet's land surface annually back in the 1980s. By 2023, it had reached 16.7%, with a 10-year average sitting around 7.9%. And the study's authors noted that the real number has almost certainly climbed even higher, since, given that 2024 set the record for the hottest year ever measured, and 2025 came in nearly as warm. One climate scientist who wasn't involved in the study but reviewed its findings put it plainly. This illustrates a key point about climate change that gets lost in a lot of day-to-day weather coverage. The most damaging impacts often don't come from a single extreme event. They come from compound extremes, multiple hazards, stacking on top of each other and amplifying one another. When heat waves, drought, and wildfire risk all show up together, the way they did in the 2010 Russian heat wave or the 2019-2020 Australian bushfires, the impacts escalate far faster than any one hazard would produce alone. Here's the mechanism behind this, because it's not just hot weather eventually leads to dry weather in some vague sense. There's a specific physical process at work, and understanding it is the key to understanding why this pattern is intensifying. Warmer air holds more moisture, and it also demands more moisture from everything around it. Scientists sometimes describe this by saying warmer air gets thirstier. When a heat wave settles over a region, that thirstier air starts pulling moisture directly out of the soil at an accelerated rate, a process called evapotranspiration. Under normal conditions, the moisture loss happens gradually enough that rainfall and other water inputs can keep pace with it. But during an intense, sustained heat wave, the rate of moisture loss from the soil can spike dramatically in a very short window, sometimes just a few weeks. That's what produces what's known as a flash drought, a drought that develops far faster than the slow, multi-season droughts most people picture when they hear the word. The 2021 Pacific Northwest heat dome is the example climate scientists keep returning to as the clearest recent case of this pattern in action. That heat dome didn't just produce a handful of brutally hot days and then fade away cleanly. It left the soil across the region abnormally dry in its wake, priming the landscape for the drought and elevated wildfire risk that followed in the months after. One researcher who lives in the Pacific Northwest and studies this exact phenomenon called it one of the clearest examples of a hazard. Scientists are now watching accelerate globally, not a one-off regional fluke. Other recent examples, researchers point to include the 2022 heat and drought event around China's Yangtze River, and the record heat and drought that hit the Amazon in 2023 and 2024. Different continents, different ecosystems, same underlying mechanism, heat first, drought second, and the drought arriving faster and hitting harder than the historical record would have predicted. Why this summer fits the pattern. Exactly. This isn't an abstract, future tense warning. It maps directly onto what's already happened across multiple continents this year. Scientists at Climate Central opened a briefing earlier this summer by walking through how human-caused warming is contributing significantly not just to deadlier heat waves on their own, but to intensified storms and wildfires that follow in their wake. Separately, a former NASA climate scientist reinforced his own warning that many researchers are still underestimating just how sensitive Earth's climate system is to rising greenhouse gas levels. He also warned that 2026 is on pace to become the planet's warmest year ever recorded, despite starting out cooler than the previous record year. Europe lived through a brutal example of this compounding danger earlier this summer, with a heat wave linked to more than 1,300 deaths across the continent. A rapid response scientific analysis released in the aftermath was direct about the cause. Fossil fuel emissions have rapidly worsened European heat waves within just a few decades. The same analysis found that the intensity of daytime heat recorded this June would have been roughly 10 times less likely to occur back in 2003, during the continent's first major heat wave of this century. It also found that nighttime temperatures at the levels recorded this June would have been more than 100 times less likely to occur just over 20 years ago. Right around that same period, extreme heat warnings stretched across the Midwest, the Mid-Atlantic, and the Northeast United States, covering the entire heavily populated Interstate 95 corridor from Virginia up through southern Maine, with widespread temperatures pushing past 100 degrees. Forecasters specifically flagged that overnight lows sitting in the mid-70s to low 80s would offer no real relief from the heat. Exactly the compounding, no recovery window dynamic we've discussed on this channel before. That's not a coincidence. It's the same underlying pattern showing up in a new location. The hurricane connection, nobody's talking about. There's a second compounding threat scientists are increasingly focused on, and it's one that gets very little mainstream coverage despite how serious the research behind it is. It's the danger of extreme heat arriving immediately after a hurricane, rather than before one. A 2019 research paper on what scientists call the tropical cyclone deadly heat compound hazard found that under the historical climate baseline running from 1980 to 2010, this kind of event, a major storm followed closely by a dangerous heat wave, had roughly a 1 in 10 year recurrence frequency globally. But the same research found that at 2 degrees Celsius of global warming, a threshold the planet is now closing in on, that frequency would increase by nearly a factor of 4 to 11 such events over a 30-year window instead of 3. And the researchers who conducted this analysis noted their own numbers likely understate the real risk, because their model only accounted for changes in heat patterns. It didn't factor in that future hurricanes are also expected to be stronger, wetter, and slower moving, all of which increases their potential to knock out power grids for extended periods. Here's why that combination is so dangerous. A hurricane can take out electricity, and with it, air conditioning, across an entire region for days. If an intense heat wave settles in immediately afterward, exactly the kind of event this research says is becoming 4 times more likely, you get a population already dealing with storm damage, no power, and potentially no reliable water access, suddenly facing dangerous heat with none of the tools most people rely on to cope with it. The storm isn't the whole disaster anymore. It's the setup for the next one. The bigger picture, why 2026 keeps breaking records. All of this is unfolding against a backdrop that climate scientists describe as deeply unusual, even to researchers who have spent their careers expecting exactly this kind of warming. The UK's Met Office projects that global temperatures in 2026 will land between 1.34 and 1.58 degrees Celsius above the pre-industrial average, with a central estimate of 1.46 degrees. If that holds, it would mark the 4th consecutive year the planet has stayed above the 1.4 degree threshold. It puts the world uncomfortably close to the 1.5 degree target set under the Paris Agreement, a line researchers have spent years describing as a critical threshold for triggering more severe and harder to reverse climate impacts. An ongoing El Niño, officially declared earlier this summer, is adding additional fuel to this year's heat. Climate researchers are careful to note that El Niño's strongest effects on extreme heat typically show up a few months after it forms and strengthens, rather than immediately. That means some of El Niño's contribution to this year's extreme heat may still be ahead of us rather than already behind us, which lines up with the worst may still be coming pattern we keep seeing across every one of these interconnected hazards this summer. One prominent atmospheric scientist summarized the core issue about as clearly as it can be stated. The primary driver behind the recent uptick in deadly heat waves worldwide is the ongoing burning of fossil fuels. Even a modest amount of baseline warming produces an exponential increase in how often extreme heat actually occurs. That word, exponential, is doing real work in that sentence. It means the relationship between warming and extreme heat frequency is not a straight line. Small increases in baseline temperature translate into disproportionately larger increases in how often truly dangerous heat events occur. Why official drought warnings are often already behind. One of the most important and least understood details in this entire story is that traditional drought monitoring systems were largely built to track a slower, older kind of drought. The multi-season, sometimes multi-year droughts caused by a sustained lack of rainfall. Flash droughts break that model because they're driven primarily by evaporative demand from extreme heat rather than by rainfall deficits building up gradually over months. That distinction has real consequences for how fast the public actually finds out they're in one. A region can look completely normal on a standard precipitation map, having received close to an average amount of rainfall for the season, while simultaneously sliding into a severe flash drought, because the heat has been pulling moisture out of the soil faster than any reasonable rainfall could replace it. Some drought monitoring systems have started incorporating soil moisture sensors and evapotranspiration data specifically to catch this faster-moving version of the hazard. But the official classification and declaration process in many regions still tends to lag behind how quickly conditions on the ground are actually deteriorating. By the time an official flash drought designation is issued in some areas, agricultural losses and elevated fire risk may already be well underway. This is part of why researchers studying this trend keep emphasizing that flash droughts require a different kind of public awareness than traditional droughts. You cannot necessarily wait for an official declaration as your signal to start taking water conservation or fire risk precautions seriously. If your region has just come through several weeks of intense, unusual heat, the soil beneath you may already be drying out at a rate the seasonal rainfall outlook never anticipated, regardless of what the most recent official drought map is currently showing. The direct line from flash drought to fire season. This connects directly to something we've covered on this channel already this summer, the wildfire activity currently burning across Canada. No AA has been explicit about the mechanism linking rising global temperatures to wildfire severity. Hotter conditions reduce moisture in soils. That reduced soil moisture is precisely what transforms a landscape from merely dry into genuinely primed to burn. A flash drought doesn't just dry out topsoil, it dries out the dead grass, fallen branches, and undergrowth that make up what fire scientists call fine fuels, the material that ignites first and carries fire fastest across a landscape. Under normal moisture conditions, that fuel layer retains enough water content to resist ignition from a stray ember or a lightning strike. Once a flash drought has pulled that moisture out over just a few weeks, the same fuel layer can become dangerously receptive to ignition almost overnight. This is part of why wildfire outbreaks so often follow closely on the heels of an intense heat wave rather than trailing months behind it. The 2021 Pacific Northwest heat dome we described earlier didn't just produce a flash drought in the months that followed. That same drying trend fed directly into the elevated wildfire risk the region experienced through the rest of that fire season. Put all three pieces together, and you get the full chain this video has been building toward. An intense heat wave dries out the soil faster than normal seasonal patterns would predict. That accelerated drying produces a flash drought that conventional monitoring may not catch immediately. And that flash drought primes the landscape with dry fuel exactly when wildfire risk is already elevated by the heat itself. 3 stages, one accelerating sequence, and increasingly, very little time between each stage and the next. The historical cases scientists keep returning to. When researchers want to illustrate just how destructive this compound sequence can become when every stage lines up, they tend to return to the same handful of case studies. It's worth understanding why these specific events became the reference points they are. The 2010 Russian heat wave remains one of the starkest examples on record. An intense, prolonged heat dome settled over western Russia, and in its wake came both severe agricultural drought and one of the most destructive wildfire seasons the region had experienced in decades. Smoke blanketed Moscow badly enough to force flight cancellations and overwhelm the city's emergency services. The heat wave itself was deadly. What followed compounded that death toll considerably further. The 2019 to 2020 Australian bushfire season is the other event climate scientists point to constantly, and for good reason. An exceptionally hot, dry spring primed the continent's vegetation months before the fires most people remember actually ignited. By the time the worst of the burning arrived that southern hemisphere summer, the landscape had already been prepared for it by exactly the kind of accelerated moisture loss this newer research is now able to quantify and track globally, rather than recognize only in hindsight one region at a time. What makes the current research genuinely new is not the discovery that heat can lead to drought, which scientists have understood in general terms for a long time. It's the ability to measure how much more frequently and how much faster that specific sequence is now completing itself worldwide. It also shows, with actual global data rather than a handful of well-known case studies, that events like Russia in 2010 and Australia in 2019 are not historical outliers. They're becoming the expected pattern. What this actually means going forward. So let's bring this back to something practical, because understanding the mechanism behind flash droughts and compound disasters matters most when it changes how you prepare for what's coming. If you live in a region that just went through a significant heat wave this summer, the period immediately following it is not necessarily a period of relief. Based on what this research shows, it can be a period of elevated risk for a different hazard entirely. Rapidly drying soil, elevated wildfire danger, and water stress, even if rainfall totals for the season look roughly normal on paper. This is part of why we've spent time on this channel recently covering both the reloading heat dome pattern across the US and the wildfire season already burning across Canada. These are not 3 separate, unrelated stories. They're increasingly connected links in the same chain that researchers are now tracking as a single, accelerating phenomenon. If you're in a region with agricultural interests, or you rely on a private well or a water system with limited reserves, this is exactly the kind of research that should inform decisions about water conservation proactively, rather than waiting for an official drought declaration that, by definition, tends to lag behind how fast a flash drought can actually develop. And if you live somewhere prone to hurricanes, this research is a strong argument for making sure your emergency preparedness plan accounts for the possibility of extended power loss overlapping with dangerous heat, not just the storm itself. For a long time, the public conversation around climate change tended to focus on individual record-breaking events in isolation. The hottest day ever recorded in a particular city, the strongest storm of a given season. What this research, and honestly what this entire summer is telling us, is that the more dangerous story is what happens when these individual records start interacting with each other. A heat wave that primes the soil for a flash drought. A flash drought that primes a landscape for extreme wildfire risk. A hurricane that knocks out power right before a heat wave arrives to fill the void. None of these are separate disasters anymore. They're stages in a single accelerating sequence, and the data increasingly shows that sequence completing itself faster than it used to. We'll keep tracking every piece of this as it develops. The heat, the drought risk that follows it, the wildfire activity it feeds into, and the storm season still building ahead of us. Subscribe so you don't miss any of it. Drop a comment and tell me whether you've noticed this pattern where you live. A hot stretch followed almost immediately by unusually dry conditions. I rate every one of these, and I want to know what you're actually seeing on the ground. Stay safe out there, and I'll see you in the next on